Hey everyone, just thought I would hop on and explain how to do a couple of these problems. So here's one. First thing I would do is obviously identify the parent function. So this has a v-shaped graph, it's got to be our absolute value graph. And then for me, I think it's helpful to kind of list out what changes are happening. So I know that that main point has moved left one and down one. Okay, so I noted those. But the other thing that's different is that normally the parent function starts at 0, 0 and goes up 1 over 1, up 1 over 1, right? That's not happening here. So even from my center point, I'm not going up 1 over 1. So what has happened, the point should be right here if I didn't change it. But where is it? It's right here. So that means the y value, instead of being at 1, is now at 2. So how did I get there? I took my y value and I multiplied it by 2. Okay, same thing, the next one should be, so we have one at 1, 1, the next one should be right here, but it's not here, it's up here. So you can see that, yep, my y value has been doubled. So I just note that I need to multiply my y values by 2. So once I have these things that I know I need to incorporate into my equation, then I actually come back up, I go ahead and I can figure out the answer. So a left one, down one, that's easy enough. Make sure that if I'm moving left to right, that's in there with the x, and it's the opposite of what we really want to do. So left is going to appear as a +1. And then down 1 we know is just going to be a -1 on the end. And then if I'm going to multiply the y values by 2, I make sure I pop that 2 on the outside there. These, they're tricky, so I highly recommend that once you have your equation, go back and plug in a point and make sure that it all makes sense. Okay, so take any point on your final graph. So -1, -1, for example. If I plug in -1, I'm expecting to get out -1 for y. So let's just see. -1 plus 1 is 0. Absolute value of 0 is 0 times 2 is 0. 0 minus 1 is -1. So I'm fairly certain that I have this right. Feel free to double check with any other points, but please, when you are done writing the equation, always check, because it's very easy to put something in the wrong spot, write a plus when it should have been a minus. It can get really kind of tricky, especially when we move on to ones that are a little bit more complicated, like this guy. So, a couple of things. Again, I notice that the parent function is, again, x squared. And, or no, I shouldn't say again. It is x squared, right? So y equals x squared. And then the changes that I have. The whole thing's flipped upside down. So how do I acquire that? I'm going to multiply all my y values by a -1. So that'll take care of that flip. I also notice, think about what the parent normally looks like. So it starts at 0, 0, 1, 1, and then I go up 3, right? Same thing on the other side. So if I just kind of sketch the parent function, looks like that. Then, of course, we flip it over. So if I were to take that parent function and just flip it, it would look like this. But it doesn't look like that. So that's not the only thing I've done. I haven't just flipped it over. I'll try to make that a little bit better. So this point that should be right here is over here. So I've done two things to it. I've increased the x and I've increased the y. So that's going to show up as two separate things. So I noted that we're going to flip it over by multiplying all the y values by -1. But then my graph gets wider. Instead of that x value being at 1, now it's at 2. So I want to, and remember, everything's different when we're talking about the x's, right? So instead of multiplying by 2, what I really need to do in my equation is write it in the equation as 1/2 times 2, right? Because I always want to be doing the opposite when it applies to the x's, okay? But that's not the only change that has happened. So that would just put my point here, multiplying the x by 1/2. And the point is not here, it's down here. So I'm also stretching the y's. So the y was at 1, now it's at 2. So I'm going to be multiplying my y's by 2. So stretched up by multiplying y by 2. So let's put all these pieces together and see if we can come up with the correct parent function. Okay, so let's see. I'm going to multiply everything by a -1, but I'm also multiplying by 2 on my y's. So I can incorporate both of these at the same time by just multiplying by a -2. Okay, and then let's see, for the x, I want to input it as multiplying by a half. So we'll do a 1/2 x, and my parent function was x squared. So that looks okay. I notice I'm not shifting to the left, right, up, or down any, so I don't have to worry about that. Okay, so now that I have an equation that I think is correct, I'm going to go ahead and take some points and check them. I mean, you could check 0, but that's pretty easy. And even if I had messed this stuff up, I probably would think that I'm right. So let's try this point. When I plug in +2 for x, I should be getting out -2 for y. Let's try it. So if I plug in a +2, 1/2 times 2 is 1. 1 squared is 1. 1 times -2 is -2. So, fairly confident that we have this one right. I'm not going to do all of these because I want you to be trying them. But when you get to one like this, you're going to think about it the same way that we did the others. This is, hopefully you recognize the parent function as a square root. And then just think about what it normally does. So it starts here, and then it would normally be at 1, 1 for the next point. Well, it's not there. It's up here. So how do you get from here to up here? It looks like you're going to have to do something to both the x's and the y's again, because if you just change the x, the point that was here would be either here or, it would be moved. It would be at the same y value, but it would be moved left or right. And that's not the case. It's 1 over and 1 up. So same thing. If the point was supposed to be here and I was only multiplying it by the y values, it would just be somewhere else on this same vertical line, but it's not. It's over and up. So you're going to have to do something to both the x's and the y's. Okay. When you get to number 4, this one, remember that your reciprocal graphs have these asymptotes, right? So I have an asymptote there, and I have another asymptote there. And the parent function had me graphing. It was normally at the x and y axis. And 1, 1 was our point. So if these are my new asymptotes, I would normally be here at 1, 1, but I'm not here, I'm here. So how did that happen? So I know I'm going to pick up my whole graph, and it looks like I'm shifting to the left 1, up 2, but then I also don't have my graph here and here like I normally would. So how did they make the branches move here and here? Okay, so think about that. All right, and then there's 2 more for you to try. I will post the answers to this, but hopefully that little tidbit helps.